Good afternoon. My name is Matt Aro. I work for the University of Minnesota Duluth Natural Resources Research Institute. This tall plant, as you're aware of, is a plant called Tifa australis. It's a fast-growing aquatic invasive plant that's choked out waterways. Many people have called it the desiccation machine, meaning this plant absorbs water and chokes out waterways, creates a lot of problems, which I'll touch on briefly here. Our concept is to take this plant and process it in a unique way to produce a new biofuel product for heating and cooking purposes in West Africa. The regions that we're looking at in West Africa along the Senegal River Valley in Senegal and Mauritania, these families and these villagers make approximately 87,000 guia, which is about $300 US per year. About 30 million people are adversely affected by the Tifa pestilence. In the Senegal River Valley, approximately 350,000 acres of the river is choked out by the Tifa plant. Some of the main problems caused by the Tifa: reduction in fishing productivity, reduction in the rice crop productivity, chokes out the waterways, livestock cannot access to water, the villagers don't have access to clean water, and the stagnant water in the Tifa stands support malaria and other aquatic waterborne diseases such as bilharzia as well.
Is this an invasive?
Excuse me?
Is this an invasive species?
Yeah. So our concept in a nutshell is to take green Tifa stalks, we don't have to dry the Tifa beforehand, and to process it using a technology that we developed called hydrothermal carbonization. When we take Tifa, we produce a product that we call biocoal. And we make cooking and heating fuels. We can take the biocoal, we can make pucks, we can make briquettes, we can make pellets, we can make it essentially any shape that the end user desires, which is convenient for them to burn. And a process that typically takes millions of years in nature, making coal, using hydrothermal carbonization, we can essentially do it in just a matter of minutes. Some of the advantage of our coal product compared to the competitors is it's clean burning, it's dust free, it's water resistant, it's rot resistant, and it's very high energy density. Energy recovery values are actually very similar to the major fossil coal brands, so it's very high BTU value, almost 11,000 BTUs on average. Another key point is there are regions in the Senegal River Valley that don't have access to basically any type of fuel. This is a picture of a village where they're cooking fish over cardboard. They have access only to cardboard, and the fish don't cook very well over cardboard. They scorch and they burn really well. So we may be able to provide an alternative fuel source, new fuel source for these folks. Our customers, we believe, is the government of Mauritania, and you have shown interest in investing in this technology. We believe the customers for the end fuel products are villagers. We've seen some pictures of the villagers here. And also, potentially, if one of these plants, one of these manufacturing facilities can make surplus fuel, there may be vendors that are interested in purchasing surplus. Also, we believe the interest is not only in the finished product, but also the manufacturing plant. So there may be other investor groups that might wish to invest in a manufacturing plant to actually make the fuel product. The main competition is charcoal from acacia wood. This yellow band here is the Sahel region of Africa. Sahel is Arabic for shore. Basically, it's the dividing line between Sahara Desert to the north and the wooded savanna to the south, Mauritania and Senegal here. Folks are harvesting the acacia trees very intensively, and that leads to deforestation and desertification. Senegal loses about 115,000 acres of forest per year. Chief outcomes from this project are, if we can take our Tifa plant and make the biocoal that I just talked about, improved health due to better access to clean water and reduction in malaria and other waterborne diseases such as bilharzia, leading to increased family incomes, incentive to harvest the Tifa, improve fishing productivity, and improved rice crop productivity as well, leading, we believe, to overall improved quality of life. And our business model is, we've proven this, validated on the bench scale in our laboratory, as you're aware of. So our plan, as you've seen in our proposal, is to construct a pilot plant and build the pilot plant in Duluth, Minnesota, ship it to Mauritania, set it up near Rosso, Mauritania, and actually start making these fuel products in Africa. And then run suitability trials with the local villagers to find out what they think of the fuel. Does it burn hot enough? Does it smell okay? Is the shape acceptable? Do you want a briquette that's bigger? Do you want a puck? Do you want a pellet? All these questions we need to answer. And from that we can learn what we think is a better way to do this and optimize the production process. Key assumptions and unknowns so far. You can see our assumptions here. Big unknowns are, if we had a plant, a manufacturing plant to make this product, how far out can we go to harvest the TIFA? We know the TIFA grows some in lakes, but also heavily along the shoreline of the Senegal River. And what we don't know is, does it grow 30 yards out from the shoreline? Does it grow 50 yards out from the shoreline? So if we have the river here, do we have a plant here? Does it make sense? Could we have another plant 80 kilometers up the shore? Is it 30 kilometers? And those are things that we don't know yet until we can conduct some of these suitability trials in Mauritania. We won't be able to answer those just yet. So we've estimated increase in family income using data that was provided to us by Ismail Kane from your ministry. On average, as I said early on, the average family makes about 87,000 guia. We believe that if 60% of their acacia charcoal use is substituted with our new biocoal product, that increase in family income up to nearly 160,000 guia, which is nearly an 81% increase. Thank you.